Hey, on this video we are going over the last graph on the study guide, which is taking this velocity time graph and making a position time graph as well as an acceleration time graph. So this is just like the previous video. If you watch that one, we're going to walk through how to solve it. But starting off with this position graph, we're going to take the velocity graph first and divide it into sections and then find the area of each section. All right. So the first section here, we're going to divide up into this triangle. Again, you're dividing up the graph every time your line changes direction or crosses your x-axis. So we're going to get a triangle and then a rectangle. And then this other triangle here, which happens to be the same size as our first one. And then we're crossing over the x-axis. And we get one large triangle here. You could technically break this up into each, like from 6 to 8 and then 8 to 10. But you're technically just kind of making more work for yourself if you do that, but you are still going to get the correct answer if you do that. Okay, so now we've divided up. Our next step is to find our area for each section. So starting with this red triangle, we have 1/2 times its width goes from 0 to 2, so its width is 2 seconds. Its height goes up to 3, so 1/2 times 2 times 3 is going to equal 3. Then for the box, it has a width of 2 because it goes from 2 to 4, and it has a height of 3, so that is going to equal 6. Then the green triangle is the same as the red one. It goes from 2 seconds over, and it has a height of 3 as well, so 1/2 times 2 times 3, and that's going to equal 3. And then lastly, the purple triangle, we have 1/2. Its width in this case is 4 because it goes from 6 all the way to 10. And then its height goes from 0 down to -6. So that is going to equal -12 when you work that out. All right, so that is step 1, is to find all of the areas. All right, now it's time to make your position graph. So if you have a positive area, you're going to go up by that much. If it's negative, you're going to go down by that much. And you're going to start off from 0 and then add or subtract from there. All right. So for the first 2 seconds, we've gone up 3. So we're going to start from 0 and go up 3 at the 2-second mark. And then to determine our line, we want to look at what this line here is telling us. A diagonal line that's headed up on away from the x-axis on the graph is speeding up because it's going from a speed of 0 and it ends at a speed of 3. So it's going to speed up. So we want a curve that shows us we're speeding up, which means our curve is getting steeper towards the end. All right. Next up, for the blue rectangle, we have a horizontal line here. So that tells us constant velocity. So we're going to go up 6 more from where we are. So we're at 3. We want to add 6. That's going to take us to 9 in those 2 seconds. So we're going up 6 additional meters. And we want to put a diagonal line here because a diagonal line on a position graph tells us we're going at constant velocity. All right, moving on to the green triangle, we're going up a +3 more in those 2 seconds. So we're at 9. We want to add 3. That's going to take us to 12. And then we want to match our curve to our description. Here we have a diagonal line that's approaching 0. So if we're going towards 0, we are slowing down. So we want a curve that gets flatter because that tells us we're slowing down. All right. And then lastly, for this purple triangle, we are now headed down on the graph by -12. So we're at +12. We're going to subtract 12 and end up back at 0 for this one. And then we want our curve to match what it's telling us. So we are being told here we're going away from 0, so we're speeding up. So we want a curve that also shows us we're speeding up, which means your curve is going to get steeper as you go through it. All right, so that's your position time graph. So again, step 1, break your graph up into sections. Step 2, find all your areas. Step 3, plot your position graph using your areas and matching your descriptions. All right, moving on to making your acceleration graph from your velocity graph. So this is the same velocity graph. All right, we're gonna, this time, instead of using area, you're using slope. So we're gonna go go ahead and find the slopes for each of the sections, and you're finding slope every time your line changes direction or changes slope. All right, so the first 2 seconds, it's going, it's maintaining that same slope. So your rise here is going from 0 up to 3, and the run there is going over 2. So 3 divided by 2 would be 1.5. Right, for the next 2 seconds here from 2 to 4, you have a horizontal line, so you already know that it's going to be 0 there. All right. Now for this next section, you could find each of these sections separately, but if you look carefully, you'll notice it's dropping by 3 here, it's dropping by 3 there, and it's dropping by 3 there, all across 2-second intervals. So all of these are going the same slope. So you could find that all at once. If you found them all separately, you're going to get the same answer, I promise. All right. So here for the purple that I've drawn over very poorly, you're going from 3 down to -6. So that's a total drop of -9. And that's occurring from 4 to 10 seconds. So that's a 6-second difference. So -9 divided by 6 is equal to a -1.5. Okay, so those are all your slopes. So that is, again, step 1, find all your slopes. So now we're going to plot our line. So for the blue section here, our slope was 1.5. So on our acceleration graph, we're going to put a line at 1.5. Unfortunately, my graph paper here is not labeled in 0.5 increments, but we can kind of go between 1 and 2 and label that there. So that's going to go for the first 2 seconds. Your second 2 seconds is at 0. And then the last 3 sections of my graph are -1.5, so that from 4 to 10 seconds, I am going to be at -1.5 that entire time. And then we can just go through and connect these with dashed lines, and we're done. All right, so again, for acceleration graphs, step 1, find your slopes for each section, and that's every time your line changes slope, or you can see it as like changing direction. All right. And then once you find your slopes, that's where you're going to put the horizontal line at that number value for that time interval, right? So they are really easy to do once you get the hang of it, right? But if you have any questions, please let me know.